Good morning, everyone. Welcome to this panel. My name's Helen Massey-Beresford. I'm the European Air Transport Editor at Aviation Week. We're here today to talk about artificial intelligence and other new technologies when it comes to aviation safety. So first, let me introduce my panel. We have Florian Guillemet, who is the Executive Director of EASA, Mary Lombardo, Vice President Advanced Technologies at Collins Aerospace, and Pascal Andrei, Chief Security Officer at Airbus. So welcome everyone, and thanks for speaking to us today. Can I start with a quite broad question? What opportunities do AI and technologies like machine learning offer commercial aviation? We can think about on board the aircraft, but also in the wider aviation ecosystem. I don't know who would like to start, but perhaps Mary, would you like to start?
Sure, I can start. You know, for the aviation, I think artificial intelligence provides a huge amount of opportunity across the board, whether it be working on airport operations to just help decide and optimize gate selection, or whether it's on-wing maintenance capabilities, or even being able to assist the pilot in very complex operations, like as kind of a co-pilot's pilot.
I can continue. So on the aircraft manufacturer side, the artificial intelligence in general, but machine learning more particularly, are used for a couple of years now in many areas. In the design of aircraft, for instance, now we have the DDMS, the famous DDMS, which is digital data manufacturing services. There is also the certification process. We have enhanced we've boosted the certification process of the A350, now the new generations of aircraft. We have also the hybrid modeling systems on the design phase. On the security side, the SOC, the Security Operating Center, is also using now more and more artificial intelligence and particular systems to enhance the protection of the company. We are also using AI on the formal proof to ensure all the software design on board the aircraft is well done. And then, in a broader way, we are using also artificial intelligence for passenger experience on the aircraft. We are also using the predictive maintenance is also a very strong service we related on artificial intelligence, flight operations, ATM, so many ways to use artificial intelligence in aerospace.
Thank you. Can I just come back to something you said, Mary, and Florian, we will have your views in a minute. But you mentioned the idea of the sort of co-pilot. I mean, I just wondered, do you feel like there's a strong demand from airlines to have manufacturers, technology specialists make the most of these kind of technologies? Is that something that they're really sort of asking for? And if so, you know, is there a strong demand for that?
I feel like relative to safety, there's a strong demand to be able to help our pilots, our air traffic controllers, simplify their roles, be able to quickly make decisions based off of relevant information, right? The way Collins has taken an approach with regards to the co-pilot perspective is really as an assistant to the pilot, where the pilot or the human is always in charge of the final decision that has to be made on an aircraft. But there are a lot of routine work that gets done. There are a lot of checklists that are standardized, and to be able to offer those checklists to the pilot and even offer them to be co-run, or have that pilot be able to indicate that they would like a certain test done as part of their routine work, is it helps them instead of having to go through sort of a paper checklist and go through it all. So being able to provide that level of information clearly and accurately to the pilot for them to be able to execute the role they would normally have done it improves safety and also improves the work life of the pilot.
Okay. I mean, we're at the sort of, I suppose, early stages of integrating all these technologies and all these potential use cases. These are breakthrough technologies, and they're going to change how the industry operates. Florian, how as EASA do you kind of go about ensuring these technologies are brought in safely, and the sort of evolution they represent is managed in the best way?
Okay, so thank you, and good morning, everyone. I was reluctant to start the panel because whenever you ask a regulator about innovations, the first answer is usually a no. Maybe it can be a yes, but it's hardly ever a yes, I fully believe in it. We of course witness everything that has been said in terms of current developments, but I think to answer your question, it's a matter of mindset as well. It's a matter of understanding that today technology can bring us additional safety barriers that we cannot have without this technology. These safety barriers are coming from the exploitation typically of data that we are unable to exploit otherwise from a human being perspective without the support of tools like AI. We do see today developments indeed in many areas that have been mentioned to support, of course, operations, to support performance of the aviation system at large, be it at airport, at air navigation service providers, or in airline operation, or through the aircraft performance itself. But we see as well a number of developments that are really heading in the direction of bringing additional safety benefits. For me, the first thing to answer your question is a question of mindset, that we need to approach this with an open-minded spirit, with the understanding that technology, yes, always comes with a risk, but it comes as well with very strong assets that we didn't have in aviation so far. And the second element is that we need to work hand in hand with the industry to prepare ourselves for the certification of such product, which bring a number of challenges. We might come back on that later on with AI. But we have already developed some frameworks, which again have been prepared with the industry, that we start to apply through what we call certification special conditions. So, I mean, certification, you have to be compliant with a number of requirements which are set in the rule book. But we can as well develop some special conditions according to a framework that has been developed typically in relation to AI, for instance. So that's how we approach things. We are, of course, careful as a regulator should be, but we try as well to make sure that we embrace a new mindset of being able to bring on board these new technologies because they are bringing additional safety benefits, and this is demonstrated now.
And when you took over at EASA, you spoke about that being one of your priorities, sort of making the agency ready for this new digital era. I mean, can you give us some examples of changes that have already come into place or that you're working on in that regard?
First of all, a lot has been prepared by my predecessors, and we are not starting from scratch at all. There's been significant initiatives launched, like Data for Safety that you may have heard about, that is collecting big data from across the industry, like flight data, for instance, from the cockpits and so on. But we were in a phase where we had difficulties to move into operation. So now we are accelerating this movement. We are really starting to use this type of AI-based tool to perform some safety analysis, to run some specific operational scenarios. Maybe just to mention two of them. The first one is in relation to something we will maybe touch upon later on, GNSS interferences. This tool is collecting a number of information, like typically ADS-B in real time. This allows us to provide every week an update of the GNSS interferences around the world, and to be able to advise the airlines and the crews about the risk areas. Second, a quick example, we have a collection of information coming from incident report occurrences. This is a huge database of more than 3 million of reports that so far was not really exploited because it was exploited through a human approach, and it was pretty much manual. So now this kind of tool helps us to identify clusters, to identify trends, and to be able to be much more proactive in the identification of safety risks.
Okay, Thank you. Can I come back to a point that was touched on just a few minutes ago? The challenges of certification and these new technologies involve industry and regulators working together. And I wanted to find out from your points of view, Mary and Pascal, sort of how that looks in reality.
Yeah, I think for me, and I was going to comment this after Florian's comment, but I feel I want to give EASA a huge amount of congratulations, and they've been a wonderful partner in really looking at these new and emerging technologies. And you know, in a recent clean aviation proposal, it's called Concerto. We're really looking at that. You know, not only is the technology, you know, ready and safe, but is it certifiable? And that partnership has been really very well established with EASA, and even on things like artificial intelligence or in our approach. Both Collins and EASA published a paper through a program called Formula, which really looks at alternative methods like FUMO methods to certify artificial intelligence capabilities, and to really continue to build on creation of standards and making it a possibility for us to be able to actually tap into the capabilities of AI.
I will answer to this question and at the same time compliment of your previous question. It's clear that I'm not saying that it's since Florian arrived at EASA, but we see clearly more collaboration between EASA and industries in many ways. One example on cyber is the Part IS. Part IS in the past, in fact, the aircraft manufacturer was the one holding all the pressure on the requirements to be delivered on an aircraft from a cyber security standpoint. And we made a lot of lobbying in front of EASA, ICAO, and so on to say, don't put so much pressure on the aircraft manufacturer, just diminish the pressure, but distribute this pressure across the value chain with the supplier, the aircraft operators, airlines, airport, air navigation service providers. And this has been done. I mean, today the Part IS is coming to be applied this year. I guess it's October 2025, and it's good. And it's good, even though Florian thinks it's a bit too rush. For us, it's good. It has pushed a lot its mindset across the value chain. And now we are doing the same on AI. On the other side, because you know, generally it's always the industry who starts, and then the regulator regulates. It comes after. It's very rare that in the new technologies you have the framework before the industry. So we have started in Airbus for sure. We've started first to analyze the introduction of machine learning into the design process of the aircraft. So it's a step-by-step approach, purely from Airbus side, to ensure that during what we call the RBE, request-based engineering, we integrate progressively this new generation, while we ensure that it's fully matching with all safety conditions, design assurance level, airworthiness, and so on. At the same time, we work with EASA and some other standardization bodies on artificial intelligence in aviation, which is now becoming a new standard that you are driving, Florian. And it's a joint activity between EUROCAE and SAE, the two major standardization bodies, and it's fine. At the end, it's just a collaborative workload, which is efficient to make it happen.
Okay, just to follow up on that, when you talked about AI in the design process, which Airbus aircraft are we seeing the results on?
So we started to use machine learning on the A350, starting to accelerate the means of compliance, more especially towards the special conditions and the certification and airworthiness. Now we use it on the DDMS, as I said, for some aircraft, for single aisle, for A321 XLR, and the modifications, incremental modifications on aircraft are also using machine learning now.
And presumably you wouldn't be talking about it if it wasn't a positive step, if you weren't pleased with the results.
Yeah, it is. Yes. We don't have any new aircraft coming up, but the next aircraft that Airbus will design for sure will be more and more and fully quite fully based on machine learning.
The design in the design
On the design
phase,
phase,
yeah.
yes. On the design phase.
Yeah, in Collins Aerospace also has deployment of machine learning capabilities already in their products today. We have FlightAware, which utilizes a neural network in order to estimate the time of arrival when you utilize that app. We also offer a recommended cruise level to the pilot. It's still a pilot decision. It gives them an optimized view of how to best utilize their fuel burn, and it provides them, and that was something that we were able to work with the regulatory bodies and get a position paper in place and to be able to deploy that, so.
Okay. I just wanted to come back to what we were talking about just before. So we spoke about the importance of industry and regulator collaboration. What about cooperation between different regulators in different regions, and how important is that in this huge subject that everybody in some way or another is discovering together?
I can just speak on that one, because we are right out of a 3 days conference that we hold every year with the FAA colleagues, and it took place in Cologne this year, and it will be next year in Washington. And this is typically the topic on which we are trying to progress together, because I mean, aviation is global. There's no point in developing standards in Europe which are not compatible with what the rest of the world is doing. So we tried a bit to share as well the type of working areas, but at the end of the day, the conviction that we have is really to work jointly, using as well industry-based standards which are being co-developed, and as well ultimately bringing this to ICAO, because we need to have a global framework for a global industry.
Yeah, and as a global provider of equipment, we actually are uniquely placed because we have the opportunity to work very closely with the EASA, but we also have the opportunity to work very closely with the FAA. And so the process that I mentioned on utilizing sort of a position paper and being able to get that particular neural network approved was done both with FAA and EASA. And we've gone beyond that to other ANSPs as well.
And so I guess that, in a way, that sort of is you are a sort of bridge between the two, in some senses. You can pass on knowledge and findings.
Yes. Yeah, we've had a unique opportunity to be able to work with FAA and also publish a paper with them on similar as we've done with EASA. Being able to balance the benefits and the information from both sides of the world.
Okay, we're talking about the technologies here, but what about the human side? There must be a big challenge in sort of in the whole industry workforce throughout the, from the design to the operations, the people who work in the industry adapting to these new technologies. Is that a big challenge? Would you like to talk about that, Pascal, or?
Yeah, of course, it's a matter of competencies. Clearly, you need to hold the appropriate competencies to ensure that you can framework the difficulties of this new coming threat, because what is the threat today regarding the arrival of AI into the aviation? First of all, is do AI will overcome human in the future? This is a threat and fear that all people have, even in your daily work, in your daily life. There are many people that are afraid by in the future saying probably the AI will monitor the planet. Then we have also some fears regarding we will be able to detect misbehaviors of AI systems because we will rely more and more on them. So and also some the data we are using on the AI. So it's all a matter of the way we onboard AI on the aircraft with human. As Mary said, human will be always in the middle. I don't think that tomorrow we will have an aircraft without pilot, just flown by AI system. We will all the time have at least one pilot and probably another one on the ground. And we shared yesterday on another meeting the same opinion on automotive. The cars will never be fully automated worldwide. In some areas, like the drones, for instance, we will fly them or drive them automatically. Fully independently, but not everywhere, for sure. So human will be always in the middle, human will be always behind, and driving and trying to monitor and being the master all the time.
Okay. Mary, would you like to?
Yeah, I mean, I think for anything associated with AI, and also when you're dealing with safety of flight, it's really important that the people that are operating it really understand the basis. They need to trust that the AI is performing the way it should be performing, and that's going to require some level of retraining, right? There's like in our air traffic controller situation, there's a very much a high resistance to change, right? Because it's a very stressful role. They're continually trying to manage and operate that. So for us, it'll be really critical to be able to introduce information to them in somewhat of a seamless way that doesn't necessarily change the major portion of that, but in the end, they need to trust the information that's being provided, and that requires training.
Yeah, and time as well, I guess.
Yes.
Yeah, I mean, to me, it's a matter as well of public acceptance to a certain extent. I mean, there are technologies that today were not necessarily accepted 20 years ago, but that are now in our daily lives, and we don't question them anymore. There is a matter of education of the decision makers as well. I mean, to me, it's always quite fascinating to see how much is available from a public standpoint and how little our politicians somehow know about what you can do with technology. I mean, one example that I always mention, because that's one of the major risks we have in aviation, it's runway incursion. Today, you have the ability to spot a runway incursion pretty much on the internet through the ADS-B data in real time, and anyone can do that. And still, we are struggling to bring the technologies that we have in aviation, and in particular in air traffic management, up to speed with this type of data that is being now available. So it's crazy when you think about it from a politician standpoint, because who is going to explain that there's been an accident that anybody can spot on the internet from the public domain, and that you are not able to prevent as being professionals that domain. So to me, this is a wake-up call that we have to to make collectively. Then stepping back in my role as regulator, we are here as well to protect the system. So we have very stringent requirements, which I think is good for the industry as well, because they can throw at us ideas, and we are going to challenge them. We'll never be complacent about it, so they can be very innovative in their approach, but we will be very firm on our position. And I think this is a good tension in the system that we have, which is balancing the risk with the innovation. And to me, this is the right way to progress. Yes, it takes some time. It takes some time as well to convince people, but it takes some time as well to perform the relevant test and analysis and the proper design of those solutions.
Okay. And on a practical level, how can we kind of help operators to adapt to the changing threats, cybersecurity threats? We're going to talk in a minute, I think, about GPS spoofing and jamming, but sort of in a broader sense, practically, how can the industry help manage this?
You start?
Oh, I can start, yeah, quickly. We have to share everything we know, clearly. It's more, we have to accompany them from theory to practice. This is clear what we have to do. We have learned things already, we have implemented things, so we start with experience, probably on their side too, so we have to share more things that we do. We have to equip operator with intelligence, playbooks, and drills also, what I'm calling drills for tangible resilience. What we used to do on security in the past, each time we delivered an aircraft, we delivered the aircraft with a security handbook. We should now also start to write the AI handbook on how to play with AI on the aircraft, as we did with the security handbook in all our aircraft. And that could be also an idea to push and to steer the way that operators will implement and monitor on their side the AI.
A handbook that can be updated, presumably, quite quickly.
It's always updated, yes. It has to be updated, yeah.
So on the cyber topic, it has been mentioned. I'm already happy to have joined this event today, because that's the first time I hear that the industry is at least mindful that this is the right way forward to put in place the so-called Part IS, which is putting some requirements on the industry in relation to cybersecurity. On this topic, I really believe that this is a value chain. So indeed, it is pointless to put all the pressure and the requirements on the aircraft or on some critical system if the the rest of the chain is not addressed. I mean, having a cyber-secured aircraft without having a cyber-secured airline operation, without having cyber-secured air traffic management, airport operation doesn't make a lot of sense. So we have to work on the full chain, and that's the value somehow of the Part IS that is being implemented. It comes with a cost, so that's an additional burden on the industry. Let's be clear about that in terms of efforts, requirements, getting the right skills as well to work on such topic. You probably are very mindful of that to attract the talents in this industry to work on this type of topics is very, very challenging because there are scarce resources from that standpoint. And then, to me, it's again a matter of raising the awareness across the industry with the decision maker about the need to go for it and not to be complacent and to be determined about this. It's even more important that we are now having systems which are, if not AI-based, more and more automated. They rely on data. This means as well that this data can be corrupted intentionally, so we have to protect it, and this is as well where the entire sector is heading. So it's very important that we act much more strongly on this aspect, because otherwise we will not be able to have access to all the new things we've been talking about, because the foundation will not be there.
Okay. One of the programs that CESAR sponsors, that's really in collaboration with Airbus and Collins Aerospace, is a program called FCDI. And it's really focused on creating that cyber security framework for both for a hyper-connected ATM system. In addition, perhaps more importantly, it's really also focusing on the CNS system itself as well. And so some of the work there, and as the follow-on of that work, we'd like to see it really grow into more of a zero-trust approach. It really starts at an architect level that starts with the OEM driving that within their aircraft, within the air traffic management systems as well. That really helps enable a complete cybersecurity framework for us to be able to communicate and operate safely.
Did you want to add something, Pascal?
No, I just wanted to complement what Florian said. Clearly, the EASA has many partnerships today with industry, and it's very good. We have, first of all, the Innovation Partnership Contract, IPC, with Boeing, with Collins, which brings a lot of things, because we can share many things before certification, before regulation. Then we have the rulemaking task. MRT, I don't remember the number, I think it's 0742, something like that. Pretty useful. This rulemaking task is also involving industrials to prepare the future. And then there is for sure the working group 114 who sets the standards. And this is fine because thanks to that, EASA has been able to publish 2 papers. The first one is Artificial Intelligence Roadmap 2.0, which is useful because it gives the framework, and now there is a second one, which is still a concept one. I don't remember the exact name of this paper, but it's concept paper 2.0, which is the follow-up of this paper number 1, and to which we did participate. And that, thanks to that participation, we can just comply with it because it's part of our spirit, and we make some lobbying in it. So the collaboration between the regulators with industries is getting better and better.
If I just may pick on that, I mean, indeed, we have put in place different mechanisms. We have as well strong links, as you explained, with European programs like CESAR and Clean Aviation. For us, that's an investment to be in these activities. But we have to be mindful that in this kind of domain, we have really to work hand in hand. If we go too much behind as a regulator, we will be a blocking point because our certification requirements will not be ready when the new technology reaches the industrial maturity level. If we go too fast, too strong, we might kill innovation. So it's really a kind of proper balance that has to be reached. And just maybe one word to add, because we talk a lot about safety, which is fully relevant. But what I want to highlight is that those technologies are essential for decarbonation of aviation. I mean, there's no way we can decarbonize aviation without using such technology for better trajectories, for better operations, to reach a much more optimized degree of performance than what we have today.
And is that a big part of the roadmap, the focus on net zero as well as the safety implications?
That's part of, I would say, another roadmap, but there are means to get there, and I strongly believe that this type of technological approach is one essential component to contribute to this decarbonization roadmap.
Okay. I wanted to ask you about a hot topic, GPS spoofing and jamming. IATA recently spoke about this topic. They said they wanted an international standard to tackle this problem. They say that I think the rate of GPS outages is growing. I think it's up quite a lot in the last couple of years for fairly obvious reasons. And also they want manufacturers to kind of to tackle this problem. Do you think this call for an international standard is the right approach? And what do you see as the next steps on this issue, really?
Okay, so I'm not going to provide you a short answer. I prefer to say it up in advance. The short answer is yes, we need an international approach, but it's a very complex situation. So there are different elements. The first one is that it's strongly connected to conflict zone. That's very clear when you look at the maps. So we need to have a very strong monitoring of the situation from this standpoint. Then what we do today is containment, so that's not satisfactory. That's not something we can sustain in the long term. This containment is really based on the awareness. That's why we produce safety information bulletins that are updated in terms of maps and so on pretty much every week. Then there is the avionic component, which is a very complicated story, and we issued 1 year ago an investigation which we call a CARI, which is a call to the industry to provide us with information on the behavior of the avionics. 1 year after, we have not completed the analysis and the full collection of the data, because there are probably as many avionics as aircraft. I'm exaggerating, but it's a very complex system, and the GNSS interferences is not just impacting the navigation, it's impacting the time reference as well. So there are plenty of things that are impacted as well by this situation. So there is work on the avionics. There's work as well going on the CNS with the notion of minimum operational network, which is basically that we rely more and more on GNSS signal, but as a backup we need to have a minimum of conventional navaids and the system to cope with degraded mode. Finally, there is an area as well to look at the future in terms of technology and solution regarding the inertial capability, regarding as well some technologies that can come from the military domain. We have more and more interaction today between the civil and the military component in aviation. So all those different streams of work are happening as we speak. Today, it's not yet mature to decide the proper way forward, but it is already at the level of ICAO. And this is typically a topic that will be presented and discussed at the General Assembly that happens every 3 years in September in Montreal. How do we tackle this from a global standpoint? The last element I wanted to make is that all this relies on frequencies. And historically, in aviation, frequencies are considered as being protected. Which is not the case, frankly speaking, today. They were protected in the past because the states were much more mindful about protecting this asset, and because it was much more difficult through the available technology to have such interferences. Today we are in a totally different ballgame, and whatever we do, there is an absolute need to consider this as a critical infrastructure and to have a better protection from the states of this infrastructure.
It's a huge threat today that is growing, clearly. So I don't know if everyone knows what is the issue on GPS, but today we had in the past GPS jamming. It's when we had we lose just the GPS signals. And today, because of the conflicts in the world, but not only, we see over the conflict zones GPS spoofing. So we are a collateral victim, which means that the spoofing of the GPS is to send wrong signal, but coherent ones, to the sky, Why? Generally, because it's to divert drones or missiles. When they are GPS driven to you, you divert them, giving them wrong positions. But unfortunately, when an aircraft is flying over this zone, clearly he receives wrong information. And it's a very strong technology that they are using, because there are 3 signals coming to the aircraft. There is a ground segment 1 from the ground, there is a low orbit satellites, and then the geostationary satellite. They are able to spoof the 3 of them, sending to these flying platforms, drones, helicopters, aircraft, 3 wrong information: the positions, the time, and the altitude. In 2024, we had 80,000 declared cases on Airbus aircraft, which is huge. It's enormous. What we've seen also, it's now not only over conflict zone, but also over narco-traffickers areas, nearby the airports generally. Why? Because they want to avoid that the police can track them in Central America, for instance, and we see now in certain zones this jamming over those areas. So Airbus has launched an initiative which is made on 3 steps. The first one is the short term, which is mitigate the current risk. We had to react immediately without developing new technologies. For sure, we have to identify the zone to prepare the pilots, but we were not able to change the system on board. We have an alternate system, which is the inertial system, but it's more backup, which is drifting the time, used by the submarine, for instance, when they are underwater. Medium term is to enhance the resilience of the aircraft flying, so it will come very soon. And longer term, it's to be fully resilient, clearly. And those steps are important to certify and to ensure that it works very well, because we see that as a growing. Unfortunately, we know that it's an endless race. When we will achieve to be fully compliant or robust, they will find another way, but that's life. What is important for us today is to think about the future also. After 2030, 32, we will launch probably some initiatives. One with Galileo, ensuring the Galileo positioning system. Probably using over. We are already working on that, over antennas on the aircraft that will make more difficult the attackant to send signals on our aircraft, and then independent to GNSS time reference systems in the future. So those are the activities Airbus is working on today to ensure that progressively we mitigate the current risk, we enhance what we can do on flying aircraft, and we make an evolution of our systems in the future.
So it sounds like from both a manufacturer and a regulated point of view, there are the short-term actions to mitigate the risk, but also we're very much in a kind of information gathering phase to be able to move forward with this. And as to the question I asked earlier of is an international standard the right approach? I mean, it sounds as if the answer is yes, but when?
I don't have an answer to that as soon as possible, and I don't know exactly what an international standard means. We need to have an international reaction to it, for sure. We need to work on the different streams that we've just described. What a future standard means, I don't know if it means a new GNSS standard, whatever. That's not for tomorrow. I think what we are putting in place is a number of mitigation actions which preserve the capability of the system. But to move to a new system with a new standard, this will take years, that's for sure. So again, the idea is to have a coordinated approach to the answer we can provide today. And this is what is happening right now. And again, why the case was raised at the ICAO level, because the states have a responsibility in both, I will say, the cause of those interferences, but as well in the answers they can provide to protect as well the frequencies and the spectrum, which is a state responsibility.
And as you mentioned, Pascal, it's very much an evolving threat, because you can cope with what the threat is now, but who knows what it will be in 3 years.
There's an evolution, so probably on the longer term way, will be to find a fully independent solution, which means not relying on any external signal, whatever satellite or ground segment, that could come with what we call a QPS, quantum positioning system. As soon as the quantum computer will come, we will be able to find a way, I don't have the time to explain to here now, but a way to be totally independent from any external systems.
Okay. I would just, we've only got a few minutes left. We've been talking about threats and problems, so I'd like to bring us back to kind of the potential for these new technologies. Perhaps if we can, if I can ask each of the panelists what what your hopes are for the next few years in terms of these evolving technologies, what your priorities are, what you're looking into the most closely, and how you see things evolving in the near term. Maybe I'll start with you, Mary, if that's okay.
Sure. I think for Collins, I think very much like Airbus, where we're utilizing a lot of the generative AI type technologies to actually be able to help us accelerate time to market on a lot of our designs. And I didn't mention that earlier, but it is something that very much is a critical enabler for us, and that we feel that we could be a good partner to Airbus by being able to do that and do it both accurately as well as more quickly. And in some ways we're doing that is we're utilizing generative AI to actually to act as a co-pilot for software developers. And so where the software developer can actually utilize the co-pilot activity and be able to pull in normal sort of approved code that would be able to create, to help them accelerate their time to produce the overall capability. We see it also as being able, as an opportunity to optimize our designs, whether it be like sort of an electrical design, but being able to look across the myriad of capabilities that we've already done today and to be able to use the best of best and bring that front and center. Other ways in which we're utilizing AI as a enabler in terms of our product is a lot around computer vision and computer vision capabilities that will help both perception-based sensing, that helps with the biometrics in airports. Much of this, I mean, AI is here to stay. AI is going to be in and around both the way in which we do business as well as the products that we provide.
Okay, thank you. Pascal?
Let me be a little bit provocative. If I was Elon Musk, or if I was Trump saying to Elon Musk, what could be the aircraft manufacturer of the future? I'm saying that because we've been disrupted a little bit with SpaceX in the past. So some years ago, we had to face this disruption in terms of manufacturing satellites and launchers. So today, we have to think about the future aircraft. The future aircraft will be a flying digital platform with more and more embedded systems, digital embedded systems with artificial intelligence, many ways, machine learning, but all the others, based on the cloud, more and more on the cloud, data centers on the ground, totally digital. That will be the same on civil and military. So we have to think about this evolution, not to say a revolution of aircraft. For me, it's exactly the position I was 25, 30 years ago when we launched the A380. When we launched the A380, no regulation on cybersecurity, nothing. We have to design the secured architecture of the aircraft from scratch because this aircraft was so disruptive compared to the previous ones that we had to rewrite everything. And probably we are today at this time where we have to write the new page of the future aviation based on new technologies, based on the evolution of the threat that is much more stronger than we had 30 years ago. You see the number of tensions in the world, the number of conflicts. We have to fly over those countries. We have to fly with aircraft, with activists against us because we pollute the air. what they said, because we are manufacturing military aircraft, which probably are a part of the genocide in Pakistan. So many in Pakistan. No, Pakistan, in some countries, I don't say the countries. So clearly, we have to think about the future of the flying platforms right now, because we have to set now how do we protect the data, how do we become at a European level a little bit more sovereign in what we do, and that we ensure the security and the safety, by the way, that now will converge more and more in the future for the next generation of aircraft.
Okay, thank you. Florian, Pascal's just said that Airbus and its peers are writing a new page of aviation, so nice challenge for you. What are your priorities in these technologies?
It's hard to say after this, because it's already the pages maybe a bit towards the end of the book, or at least the middle of the book. There are, I think, early pages as well that we are working upon together. Again, I'm a strong believer that these technologies can bring additional safety benefits. That's something I'm trying, by the way, to push, that we develop a concept of net safety benefit, so that we have the ability as well, whenever we see that there's no interference with critical systems and the way the system will be certified, that we add an additional layer of safety onto it at a faster pace, because I strongly believe this will save lives at the end of the day. I believe as well that we have to apply those technologies in many domains of aviation, where today we are still relying on antiquated methods. I mean, I have an air traffic management background, and I mean, you probably know that to talk to an aircraft today, we still use VHF radio, and we actually talk and we don't send so much data. I mean, a lot of the safety barriers that we have rely on the proper understanding between the pilot and the controllers. That's why there is this read back from the pilot to each and every instruction, but sometimes the two don't match, and nobody spots it, and that's a safety barrier that falls apart. So there are projects today to listen to the frequency constantly, and for tools to detect when there is such a mismatch. I really believe this is one of the main cause of incidents that we have, that can be in the short term complemented with safety barriers that comes from those technologies. So there are plenty of examples like that. There is a mindset we have to change. Aviation is really adverse to change to a large extent. We have, as a regulator, again, we have the duty to make sure that we stay on track and that we are very stringent in terms of our requirements. But at the same time, we have a duty to make sure that we facilitate and accelerate the pace of technology when it brings net safety benefits.
Okay, thank you. We've got 40 seconds left, so I'm going to wrap it up there. Thank you, all three of you, for taking part today. That was really interesting, and sounds like you've all got your work cut out, so good luck. Thank you, everyone, and thank you for listening.
Thank you.